Okay.
Whose dog is barking? Do you guys see that, or is that just in my house?
No, we can hear it. Is it Danielle? Is it your dog?
No, it's not mine, but it's in the street.
Oh, it's a neighbor.
Yeah.
All right. Well, I shirked my duties and not super prepared, so why don't I not lead this one?
Prepared. Are you guys on the preparation assignment?
Yeah.
Yeah.
All right. So for number one, which hypothesis between null and alternative hypothesis is the hypothesis of no effect, or no difference, or status quo, or is assumed to be true? It's the null hypothesis.
Yeah.
Right.
These are pretty straightforward.
Yep.
Does the alternative hypothesis below represent a one-sided or two-sided alternative hypothesis?
I'd say one-sided.
It's one-sided.
Yeah, it's one-sided.
Okay.
3, fill in. So for a type 1 hypothesis, or a type 1 like false thing, you're rejecting a true null hypothesis. So if the status quo is true and you say it's not true, then that's a type 1 error.
Okay.
And then a type 2 is the inverse of that. If the null hypothesis is false, but you say it's true, then that's a type 2 error.
Right.
Oh. Okay.
And then let's see. Define the level of significance in a hypothesis test. With which Greek letter is it denoted? The level of significance is I don't know. I don't remember how to define it. I just know that it's the Greek letter alpha.
Alpha is significance.
Yeah, and it's a type 1 letter, or it's a type 1 error.
Right.
I don't know if I define very well why that is the number that can be used to determine if the p-value is small enough to reject the null hypothesis.
Okay.
Yeah.
So the probability is small enough that you can reject the null hypothesis?
Yeah.
Okay.
So as the value of alpha gets greater, what does that mean for the?
It means that
significance of it?
It would mean that the null hypothesis is true?
I think it just gives you more margin of error. So like if you have more margin of error, then it's not as hard to make your hypothesis true. More, if you have I don't know, it's easier to hit the target. So you're right more often.
Okay, so like that P comes though from you're testing whether the null hypothesis is, you're testing the probability of the null hypothesis.
Yes.
And so when that is low, you can reject it.
Yes.
Okay, I understand that now.
I think that's what the reading is saying.
Yeah.
For 5 was just the z-score formula.
Yeah.
So it's z equals your value minus the mean divided by the standard deviation divided by the square root of your however many numbers you're testing.
Okay.
6, define the p-value. How is it used in a hypothesis test? So the p-value describes outliers.
Okay.
At least I'm pretty sure that's what it describes. And then it just like describes an anomaly. So like your hypothesis is true, but you might have like part of your data like that's way far away from that. And so it could be an error with calculation, it could be an error with just lots of things, or it's just like a random happenstance.
Right.
That you can't really account for because it's always going to happen.
Right.
It's like someone getting lung cancer who doesn't smoke. Like usually we just assume people who get lung cancer are smokers.
Right.
But every once in a while you're gonna see one that just has it. It just happens.
Okay. So on the preparation key, it gives a definition. It says the p-value is the probability that you will observe the sample test statistic you did, or one more extreme, assuming the null hypothesis is true. So I think that the extreme is what you're talking about with outliers, or the probability that you will see something that is not normal. Okay.
And then 7. The null hypothesis is rejected in a hypothesis test. What is concluded about the alternative hypothesis?
It's true.
Yeah.
Yeah.
It's either true or not true.
Right.
And if
Or like if you disprove the null hypothesis and disprove your hypothesis, well, you need to come up with a new one.
Yeah, you need a new study. Okay. 8. Think of a couple examples where you have seen hypothesis testing in real life. So I used to watch TV, and my mom would be on the other side of the house, and I would call her on my cell phone and ask her to bring me a glass of water, because I didn't want to get up and go get one.
Right.
So my hypothesis was, if I call her enough times, she'll eventually do it. Now, I never actually collected the number to see how many times I had to call for it to work, but
it did work.
Every once in a while.
Yeah. Okay.
I'm gonna come up with one too.
All right. Let me think of one.
Think of a couple of examples where you have seen. I don't know if it's like a hypothesis, but in MTC, when the missionaries are like are desobedientes, son desobedientes.
They're disobedient.
I don't know how to explain. They are not obeying the rules.
Right.
I think there is like a hypothesis, because you can say like the missionary is not doing well, and you can say, and the other hypothesis is the missionary is doing well. So
your hypothesis is, if a missionary isn't doing well, it's probably because they're disobedient.
Yeah. So
I think that's fair to say. I think there's going to be some outliers, like people who are obedient but like have depression or anxiety, but they are obedient. So those would be the outliers. But in general, the normal is that if you're like struggling, it's probably because you're not being obedient. Yeah, I can see that. So mine, I was thinking of a gospel one too, and I think that every time we, or like maybe not every time, but the first time that we really try to get an answer to prayer, that it was kind of like I don't know, I don't want to say our null hypothesis was that we wouldn't get an answer, because everybody tells us that we will get an answer. And our alternative hypothesis isn't like, if I pray, I don't think I'm going to get an answer. But maybe to the world, it seems like the null hypothesis is that there's no God and you won't get any answer. And so your alternative hypothesis is, well, I think if I pray and I do these things I'm supposed to, then God's going to give me an answer. And so then you test it, and then now you've proved that null hypothesis that he doesn't answer prayers wrong.
Yeah, totally true.
Okay.
9. So
Okay,
the Graduate Management Admissions Test, the GMAT, is used as an admissions criterion in many Masters in Business Administration programs. The score of the GMAT in the past have a mean score of 529. The BYU professor feels now that the score has improved within the last couple of years. So determine the null and alternative hypothesis. What do you guys think those would be?
The null is that the mean score is still 529.
Mm-hmm.
And then the alternative is that it's going to be greater than 529.
Exactly. Okay, so suppose you got evidence that the null hypothesis should be rejected. However, in reality, the mean score of students taking the exam is still 529. Was a type 1 or type 2 error committed?
So type
It's 1, right? Type 1?
Type 1 is when our alternative hypothesis is wrong, right?
Yes, when the null hypothesis is correct and we say it's wrong.
Right.
A type 2 error is when the null hypothesis is wrong and we say it's correct.
Right. And then, so I was looking on the answer key and it has like some more boxes filled in. And it says that when you fail to reject the null hypothesis, so you make some tests and then you realize that it's not correct, and so you've proven that the null hypothesis is true, it's a correct decision. And then in the other way is if you reject the null hypothesis and then you realize that the null hypothesis is actually false, then you've made a correct decision. I mean, that's commonsensical, but
yeah. But you need to do those things.
Right.
Okay. C. The analysis was done in a alpha, or the what is that value again? What's that saying? Is that it's not the p-value. Just
well, alpha, I think that is the p-value, right?
No, it's a level of significance.
Yeah.
What?
Level of significance.
Oh.
So the level of significance. So in the analysis, the level of significance is 0.01 level.
Right.
What is the probability of committing a type 1 error?
So
0.01 as a percentage is only 1%.
Right, so it's 1 out of 100 chance.
So that's not a very high level of error.
No, so it's
you're going to be right.
Right, so what you're saying is you can take that what is that called, the relevance, or the what's that number called, the alpha?
The level of significance.
So you can take the level of significance and turn it right into a p-value?
I don't know how that works.
Because
we'll figure that out as we go.
Yeah. That's what it's showing in the answer key.
Okay.
Is that there was a 1 in 100 or 1% chance that there would be a type 1 error.
Value, though?
What?
That just seems arbitrary.
Right, we don't know how they got that.
So maybe that's what we'll go through later. If we wanted to decrease the probability of making a type 2 error, would we need to increase or decrease the level of significance? So type 2 error is when the null hypothesis is incorrect and we say that it is correct.
Right, so we need to increase that probability. Meaning that most of the time the null hypothesis is wrong.
Yeah, those are inversely related.
Right, okay. Cool.
So 10. National Association of Realtors. Daniela, a realtor is someone who sells like houses. I don't know. What's the word?
No. I don't know what is happening outside. I'm sorry.
No. So Daniela, do you know what a realtor is?
I'm sorry. No.
From the question. So it says in question number 10.
Uh-huh.
Says a study by the National Association of Realtors.
Uh-huh.
And a realtor is just somebody who sells houses.
Oh.
Yeah, so we just wanted to explain that. I guess I'll keep reading. In 2004,
Thank you.
second home sales accounted for more than a third of the residential real estate transactions. According to the report, the average age of a person buying a second home as an investment rental property was 47 years. Assuming the national standard deviation was 5, a real estate agent wants to determine if the average age of those buying investment property in his area is different than the national average. He randomly selects 15 of his clients who purchased an investment property and obtained the values. Yada, yada, yada. Let me find my calculator.
Yeah, I got him.
You got him?
Yeah, so design the study. What is the population from which the realtor obtains his data? His population is his clients.
Right.
Who's bought houses from him.
Right.
How did he sample this population with a simple random sample?
Or was it convenience?
He just pulled out 15 of his clients. I mean, it doesn't say
Yeah, you're
how.
right. It says randomly selects. You're right.
And then, what is the research question? What's the average age of a person who buys a second home?
Right.
So name at least one way the realtor could have randomly selected his sample.
Name at least one way to have.
He could have numbered them all and then put them into a random generator on the internet.
Mm-hmm. I thought he could go by year and take, 10 customers per year that have bought a second house to see if that has anything to do with it to maybe teach you a little more.
Right.
If the age is getting lower or getting older.
Right. You could have asked other realtors as well for their data.
Okay.
I don't know.
Sorry.
No, yeah.
Describe the data. So graph the data on a histogram, sketch the graph, and paste. Okay, so for this one, I drew it out. And I definitely gave too many values for ages. I needed to cluster them closer together because my spread is.
Oh, yeah.
But it helps you see how skewed right it is.
Right.
And you can see how the average age is 47, which actually, I don't think that there was actually a 47-year-old that he had sampled.
Right, because I just added all the numbers up and it's 46.7, so it is 47, which is just crazy that happens.
That your mean can be a value that none of the participants actually have. Right,
and that like the odds that 15 he's gonna choose 15 people that accurately like portray the mean of a huge population. Because 30 is supposed to be the number, so it's kind of, I mean, it's not lucky, it just is what it is, but it's not normal that 15 would be completely accurate like that.
Yeah, that's funny that the national average is that, and then his random sample hits that exactly. I was just thinking that 47 came from these numbers.
Yeah. The fact that it was in line with the national average is just crazy that numbers work like that.
So basically, what this is saying then is that this is like this is a sample distribution.
Right.
So you could take that big number and then funnel it down, and this is it.
Right.
And because he only took 15, that's why this histogram is skewed right as well.
If
he had 30, it might have been a little more.
Right. A little more normal.
Distribution.
Right.
A couple other things I used to describe it are just stated as skewed right. It has a minimum value of 27 years old and a maximum value of 58.
Right. You could have done your 5-number, what is it called, summary.
27 is also an outlier. It's like way far away from the normal 20-year
Yeah.
difference.
So like, let's see what happens though if I just take away that 27.
I think you're going to be in the 50s.
Right.
Maybe not quite. Maybe like 49, 51 maybe.
Mm-hmm.
Mm-hmm.
I actually only went up to 48.
Really?
Yeah. Weird.
I guess that's why like anomalies aren't too big of a deal. They aren't too random if your
Right.
sample's large enough.
Right. But even in this, like the sample's not 30 like it's supposed to be, but it still works out. So it shows like you need to have at least like you have to have enough that it will be that your mean won't change drastically when you take one number out.
Yeah.
Okay.
What are we on? D, make inferences. Since there are only 15 pieces of data, what will you need to check?
I don't know what you need to check, but
Well, I mean, I guess like you'd have to check and see if like you're only getting outliers, because if you don't have 15, you don't have enough to really be confident in that number.
right.
If it matches what the standard is, like what the average is, so like his number is 46.7, the national is 47. Like you can check that based on that. So like now you're feeling more confident that 15 was sufficient enough for it.
Right.
If he came back and his number was like 28 or 32, he probably would have had to run a bunch more numbers and say, okay, hold on.
Right. Yeah, but if you're
accurate or not accurate.
Right, but if your goal is to prove the null hypothesis, you did that.
Mm-hmm. And you could do that with a small. I mean, more would be better, but I think he proved it there. When I read some studies for classes and stuff, and I see like their conclusions they're making based on the sample size of people they actually tested.
Right. Like the original study done on autism and vaccinations. They didn't have enough people, like, and it's crazy the way that they.
The guy was defamed. Everyone pointed the finger at him. Like that's when people actually cared and checked sources and checked facts and stuff like that.
Right, but he was defamed, but he still spread the idea that vaccinations cause autism. It's crazy.
And I just don't understand how people can like believe it still after they see.
Right.
It's evidence doesn't matter to some people.
Right. Yeah, the fact that it's an idea means that there's some credibility to it. Well, that's not true.
Yeah. Some ideas are really bad ideas.
Yeah.
It's been fun reading this chemistry stuff and like the evolution of the thought, or like just the thought process and the train of thought everyone's building on someone else, and no one gets mad at the person before them.
Right, they're like,
what you did wrong. Now we know more.
Yeah, exactly.
It was a good guess, but it wasn't right.
Yeah.
All right, we'll keep going.
Yeah, like you don't have the instruments to actually know, so okay.
Okay, state the null and alternative hypothesis. The null hypothesis was that it would be 47 years old. The alternative hypothesis is that it was 46.7. I still don't really understand this one or two-sided.
It's just one or two-sided. He didn't say like it's just different. He said it's less. Because like I think one or two-sided or two-sided means that it can be less or greater than.
Okay. And he said it was less. Because he didn't make a hypothesis.
Well, I thought in the intro to the little bit, I thought it said that he
a real estate agent wants to determine if the average age of those buying investment properties in this area is different than the national average. So I think his alternative is two-sided. He's not checking to see if it's lower or greater. He's checking to see if it's
You're right. You're right.
different.
Mhm.
Okay, let A represent 0.05. Okay. Cool. Part 3.
Yeah, we still don't know how to get that.
Compute the test statistics. What is the formula to be used? Recall our test statistics. What is Z-score?
It's
okay, so we take his mean as 46.7.
Mm-hmm.
And we subtract the mean of 47, and then we divide that by the standard deviation.
5.
5 or
So,
0.05?
What's that?
5?
Yeah, I think his standard deviation's 5. Because alpha isn't the standard deviation.
Yeah, standard deviation is 5.
Alpha is the standard deviation?
Alpha is not.
Yeah,
No,
where
no.
did you get the standard deviation from?
It's from the intro.
The problem? Yeah.
Oh, standard. Okay, I see it right there.
Yeah. So the Z-score is negative 0.06.
Negative 0.06. So that is outside of his. After writing down the general formula, input the numbers you will use, show your work. Finally, use Excel or calculator to compute your test statistics. Okay, so we got the Z-score as 0.06 or negative 0.06.
Yeah.
Okay. Compute the p-value. First, sketch a standard normal curve, graph your test statistics along the horizontal axis. Shade the appropriate to the curve. Use the normal applet to compute an area under the
I'll
curve.
pull the applet up.
Okay. And I'll draw a quick little scatter plot.
We are.
Do you know which one we're on? Daniela, we're on the.
Yeah. I am trying to open the applet.
Uh-huh. Didn't we get a thing that will make a histogram for you or a scatter plot?
I don't know. Oh, that makes a scatter
I
plot?
think it came in one of the Excel things we got.
No, I'm not sure. Oh, that QQ.
Quantitative descriptive statistics.
Yeah.
Yeah.
That makes a histogram.
Well, I'm looking at this. I'm looking at this. I'm looking at the thing on the answer key. Mm-hmm. It says that the Z-score is negative 0.207. What did I do wrong?
You have 0.3 at the top.
Yeah. Divided by 5.
Divided by 5.
Maybe I got the mean wrong when I first did it.
No, well, maybe.
I'll check that.
I think I have it written down.
Yeah, I think you gave it to us too.
I don't have it written down. I lied.
No, it's the same. 46.733.
That's weird. Well, maybe they did it wrong. Maybe they got a wrong number somewhere.
Yeah, that's weird. Because it's showing the same formula on the thing.
46.7?
Oh, no, duh. I got to use the square root of 15.
Oh, okay.
Okay, so negative 0.06. Oh no, I gotta do 0.3 divided by
It's
5.
negative. It's negative 0.3. I mean, it won't make that much of a difference.
Right, so
You're just
negative
gonna
0.3.
divide it by 5 by the
Yeah,
square.
okay, I get it. If you do it like that, it works. It's negative 0.02323. So I'll put that back in.
0.232. Yeah, 0.2323.
And we need to put that. Yeah.
Okay, so
How about the thing that gives you like the p-value and stuff like that? You want to just read to me off the different values? So I
yeah,
can plug them in. Oh,
yeah.
what's going on? My computer is freaked out.
So what? Wait, what are you wanting us to do?
Just all the 15 different values.
Oh yeah. So it's 27, 49,
27, 49,
56,
56.
45,
Uh-huh.
49,
Mm-hmm.
35,
35.
55,
Mm-hmm.
50,
Okay.
40, 46,
Mm-hmm.
48,
Mm-hmm.
38,
Mm-hmm.
58,
Okay.
51,
Okay.
56,
Mm-hmm.
and 38. What's your total?
15. With a mean of 46.733, standard deviation of 8.827. Standard error of the mean is 2.279.
Oh my.
It says confidence level 0.95, null hypothesis 10. Type of
What's
test,
that? Where'd you get that?
I took it in the quantitative inference procedures,
Hmm.
like thing that they give you.
Right.
Okay, the p-value is 9.80739 e minus 11. This is one sample t-test. I don't know what that means.
I don't know that is at all.
I think that thing is for a later lesson.
Yeah, I guess. So
Okay.
going down after we found the probability of it being whatchamacallit, if it be the probability of it being below or above the standard deviations,
Uh-huh.
that probability is 0.836.
Okay.
And so I'm looking at the key, and it's saying that the p-value is greater than the level of significance, so we failed to reject the null hypothesis.
That's in the key?
Yeah.
Where's that? I'm in the key.
The answer key? Below the graph.
Yeah.
Oh, with the applet thing.
Yeah.
Okay, I see it now.
Yeah.
The p-value is greater than the level of significance. Yes, we fail to reject the null hypothesis. So it means the null hypothesis is true.
Right. Or at least we can't reject it with this data.
Mm-hmm. So we've confirmed it with this data.
Yes.
We have insufficient evidence to conclude that the mean age of people buying a second home is different in this area than the national average. Okay.
Yeah, so what are the implications? Is that this realtor should keep targeting 47-year-olds.
To buy second homes.
Yeah.
Or people just over 47.
Right. Right.
Targeting people in their 20s is not a good idea for this.
Yeah. Over 40 is good. Below 50 is good.
Cool. All right, let's move on to the quiz.
Quizzy.
I'm going to go get some pretzels.
Smart.
Start.
The first two are true, Daniela.
Yeah.
Which hypothesis involves equality?
Equality?
It's the null hypothesis.
I think so. Okay, the p-value is the probability of obtaining a sample statistic at least as extreme as the one that we actually observed. Okay. That makes a lot more sense now. That the p-value states that there's a significant probability that you're going to get numbers at least as extreme.
Not more extreme.
No, I think starting at the same extremeness and being more extreme.
Okay, yeah. So there's relative. If the p-value is really low,
yeah,
then there's not a great chance that you're like one out of 100. Like there's only 1 out of 100 chances or times where you're going to get a value that low or lower.
right.
Or that high or higher.
Right. Okay, so remember that the p-value is the probability of obtaining. So it's the same thing again. When computing the p-value, which hypothesis do you assume to be true?
Null hypothesis again.
Yes. Because when the probability of something is greater than your level of significance, you failed to reject the null hypothesis.
Right.
Okay. Suppose the null hypothesis u equals 10. Use this information to answer the next three questions. Which of the following represents the alternative hypothesis for a two-tailed test?
The
I think
last one. Oh no, the medium.
The third
Like-
one?
The third one. Are you right?
Yeah.
Where the mean does not equal 10.
Right, because that means it could be anything other than 10. It could be 11 or it could be 9.
Mm-hmm. Or
Okay.
it could be 7.
Or 7 or 1 or 1,000.
Oh, no, that's way too far away. It can't be
Crazy.
1,000.
Sorry, that was crazy.
Which of the following represents the alternative hypothesis for a left-tailed test?
The first one.
That's what I would guess.
So I assume. So let me go and double check.
You get 2 chances on this, man.
Okay, read the next one.
Which of the following represents an alternative hypothesis for a right-tailed test? Well, I would say number 2. Usually you don't write the greater than on the left side of the equation or of the inequality.
It's the second one. Because
that-
I have this thing. I don't know if you can see.
Oh, in your notes?
Yeah.
There it is. Yep.
Yep. So just remember that if it's asking for a left-tailed, then it's less than.
Right.
Left-tailed is less than. So your alternative is less than the null.
And then right-tailed is greater than.
Nice. Greater. Okay.
Yeah.
Okay. Remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance, or alpha.
Right.
Which relationship would result in failing to reject a null hypothesis? You failed to reject the null hypothesis, therefore the p-value is greater than alpha.
Yes. Yes.
Because that just happened to us.
And then the next one is the opposite.
P-value is less than alpha.
Yep. So question 10. An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim was about 1,500. They are concerned that the true mean is actually higher than this. Which of the following would be the appropriate alternative hypothesis?
The average claim amount is greater than 1,500.
Yes.
The third one.
Oh,
Yeah.
right.
Question 11. Which of the following would be the appropriate null hypothesis?
Is equal to.
Nice. The insurance company randomly selects 40 claims and calculates a sample mean of 1650. Use this information to answer the next 3 questions. The insurance company assumes the distribution of the sample mean is normal because they chose 40. Is this a good assumption? Yes, it's a good assumption because the sample size is large.
Yeah.
13, the theorem or law. What theorem or law justifies your answer?
The central limit theorem.
The central limit theorem says that it's going to be normal. The law of large numbers says that the mean of a sample is going to be close to the mean of the population. So the numbers that they're telling us is that they found a sample mean, and so that's going to tell us what the population mean is.
Mm-hmm.
And that's the law of large numbers. The central limit theorem talks about
It's
whether
like it's large or is if the parent is right.
It talks about the distribution being more normal or being normal if the parent is normal. Like the more
or
you
if the
get,
sample size is large enough.
the more normal it is. The law of large numbers, you got to think numbers means 30 or more. So if you have a sample of 30 or more, it's a good.
Right. The mean that you get from your sample is accurate.
All right. Right. Mm-hmm.
Okay.
Thank you. Thank you.
Or we're totally wrong again, and you're right.
Maybe.
Because that's happened before.
Yeah. Which of the following is the test statistic as defined in this lesson? Oh, farts.
Test statistic.
Is it Z?
Is the test statistic? I think it's X, right? Which of the following is a test?
I think so. I think it's X with the little line over it.
I thought that was the sample mean or your value.
But is it a statistic thing?
Are you talking about the output? Is that what the statistic would be?
No, I think that the input is what we're talking about. So it probably is still X.
Because I don't see those other ones being used.
Yeah, I just looked over the stuff and I didn't see those at all. So we'll see.
A sample mean. So your sample mean is 1650. That's your statistic.
Right.
Yeah.
Okay. The historical mean of sales receipts at a grocery store is $150 with standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the hypotheses. The null hypothesis is 150, and the alternative hypothesis is that it's less than 150. She will use a level of significance of alpha equals 0.05. She then takes a simple random sample of 36 sales receipts, which is enough to be accurate, from her store and computes the mean $144. What is the z-score associated with this test? All right.
So it's
4 minus
-6 divided by
40 divided by.
Doesn't give us standard deviation.
Yeah, it does. It says $40.
Oh yeah, up on top. Gosh, I keep missing stuff.
The square root of what? 36?
6.
Yeah. I got the z-score is -0.9.
-1.
Is that just plain Jane 0.9.
Yeah.
Negative 0.9.
That's what I
Right.
got.
And what is the p-value associated with the z-score from the previous question?
So let's plug that up in
The
there.
p-value is 0.05.
No, that's the level of
That's
significance.
the level of significance.
The p-value we need to put in the applet, right?
Yeah, and I got 0.3681.
0.368.
Yeah.
What inference would you make about the null hypothesis, reject the null hypothesis?
But p is not less than 0.05.
Do you get 0.368?
Yes.
Does it need to be less than or greater than?
In order to reject it, it needs to be less than.
I thought it greater than, you got to reject it. Less
Yeah,
than versus true.
If it's greater, you need to react.
I thought we answered differently already.
No, because we rejected it before.
No, look at question 9.
No, we failed to reject it.
Yeah, look at question 9.
But her numbers reject it. Her
No,
numbers.
they don't. They don't reject it. They say it's not enough to reject it.
Oh.
No, it's not enough because the number is less, right?
What relationship would result in rejecting the null hypothesis? Yeah, the p-value being, what relationship would result in failing to reject? Okay, yeah.
So then number 18 would be?
Fail? Oh no.
What's that?
So
it's fail to reject?
Yeah,
yes, fail to
fail
reject.
to reject. What is your conclusion? We have insufficient evidence that the true population mean is 150.
That's no, because that was already true.
We have sufficient evidence that the true population mean is 150.
Not necessarily.
We have insufficient evidence that the true population is less than 150. Yeah.
I think it's that.
Right.
Okay. What are 2 types of errors that can be made when performing a hypothesis test? Oh, which of them? There are 2. Now, which one involves rejecting the null hypothesis when the null hypothesis is true? Type 1.
Yeah.
Type 1, right.
Oh, 20. Sorry, I got something going on in my eye.
A researcher decided that instead of using a level of significance of 0.05, he will use 0.01. Which of the following will be true?
I think the probability of the type 1 error will increase, right?
Right. Saying that it's wrong when it's not. I think so. Because the probability that the null hypothesis is true will increase. Yeah, I think so.
I don't know.
Well, maybe his experiment will be more scientifically valid.
No.
I think it's either 1 or the last one, because 2 and 3 don't make sense to me.
I think it's the first one.
Yeah.
Because that's what we talked about in our lesson. I don't know why you would just...
Right. If alpha equals 0.05, compute the probability of committing type 1 error. Oh, great. It's like 95. No, it's like 5 out of 100.
Rounded 2 decimals. Compute the probability of committing a type 1 error. Yeah, it's 0.05. Isn't it?
Well, no, so that's the, so you would only commit an error if you say that the null hypothesis is not true, when your p-value is less than or equal to 0.05.
I'm going to say it's 0.95.
I think it's 0.95.
And I'm going to submit.
Oh, shoot.
What?
Is it likely to do it?
I don't know. We'll see. I just submitted.
All right.
We missed 5 of them.
Oh, ouch.
We missed the last one. We missed 20.
20?
Yeah. We missed 16.
So then 20 is probably type 2 error.
Maybe.
We missed 16.
Mm-hmm. Our p-value is wrong.
Yeah.
And then we missed 14. So it's not X with the line over it.
Darn it.
We missed 13. So it is the central or law of total probability or one of those.
I think.
We might have to eat humble pie on that one.
Which one?
13.
But 12 is true?
12 is true.
Oh, I guess when it's talking about it being normal, then you're right. The central limit theorem is normal. But when it talks about the mean being close to the population mean, then it's the law of large numbers. Okay. So anything above 13?
Mm-mm.
Okay,
Well,
so
that's the first 13, right?
So what would 14 be?
12, right?
14.
Z?
Which of the following is the test statistic? Oh, S. I'm pretty sure it's S.
All right, I'll put it and submit it this time.
Maybe it's not.
Let's figure out 16 then.
S, and the 14 is S
I don't know.
or
I think
C?
I don't know either. I think it's S or Z.
Hold on, let me see here. Test statistic. It's Z.
Is C?
Well, hold on. Assuming a null hypothesis is true, we assume that the true mean body temperature of healthy adults is actually a mean of 98.6 degrees Fahrenheit. Wanting to test this claim, researchers collected data on the mean body temperatures of N equals 148 healthy adults. The mean of the observed values was X to the line over it equals 98.23 degrees Fahrenheit. Histogram of body temperature shows student population, however, standard deviation of whatever would need to be determined. So we know the standard deviation in this case. So we can use the Z-score to determine effects. This is called, Z.
Yeah, because I'm reading it says the probability of observing a Z-score that is as extreme or more extreme. So we're talking about extremes, so we're talking about Z-scores.
Yeah. Okay.
Okay. So Z. So then for 14,
16.
Or 16. How did I do that wrong? Okay. So
the p-value, it's a probability that we would get a Z-score that is as extreme or more extreme.
I think it's because I did both sides. I think it's just the one side.
Uh-huh.
And so it's...
We are in 16?
If it's two-tailed, then you do both sides.
Right, and it's just less than, right?
Uh-huh.
So then the probability is not, it's half of 3.368, which is
okay, using the applet, we will shade the area in both tails and then type in the Z score.
Yeah.
And then the applet reports the area at the top.
Right.
And then this is the way computers indicate scientific notation expressed using more traditional notation, we get p-value equals, and then whatever the number is. You should always convert the computer's notation involving e to scientific notation.
Yeah, so the p-value is 0.184 because it's just the one side.
Uh-huh.
A4.
Is that it? There's no like...
Well, it's 0.1841.
Not like times... It's not like times 10 to the anything?
No. If we wanted to make it scientific notation, we'd say 1.84 times 10 to the negative 1.
Yeah, we don't need to do that.
Okay, so 16 is wrong. You said what else was wrong?
20?
So 20, I think it would decrease, or the type 2 then would increase. Because you would think that the null hypothesis is wrong when it might not be wrong. I mean, not the null, the alternative hypothesis.
20?
Yeah.
Type 2 is saying a null hypothesis is correct when in fact it's actually incorrect.
Right. So if you just lower the alpha score or the alpha down, it makes it really impossible to prove the null hypothesis wrong.
Mm-hmm.
Right.
Okay. And then 21 we got.
I got. Oh, 21.
But I guess the third answer on question 20 might be what we're looking for too, though.
The probability that the null hypothesis is true will decrease.
No, the number 2 still works better.
The probability of type 2 error will increase?
Yeah, so saying that the null hypothesis is true when it's not.
Mm-hmm.
Well.
And then what? 21 was wrong?
Yeah.
So compute the probability of committing a type 1 error. So it's saying that the null hypothesis is wrong when it's not. I guess that's really low, so I think you might have been right that it's 0.05.
Okay.
I'll submit that.
I can submit it and see.
Yeah, you should wait though.
We're gonna have to use yours too.
Okay.
Mm-hmm.
100%.
Sweet. Okay, hold on. Read me off the answers as soon as I get back in.
Okay. So you can submit yours now, Daniela.
Yes, please. Yeah, 100.
Awesome. Okay, I'm gonna just read him off his if you can stay, and then I'll just turn the recording off after though.
Which hypothesis involves equality is the null hypothesis?
Yeah. Okay. So 4 is null.
Null. 5 is.
5 doesn't equal.
6 is.
Less than.
The mean is less than 10.
Yeah. And then 7 is the mean is greater than 10.
Mm-hmm. 8, the
p-value.
8
is the p-value is greater than alpha.
Mm-hmm. And then
9 is the p-value is less than alpha.
Mm-hmm.
10 is the average claim amount is greater than 1,500.
Okay.
11, the average claim amount is equal to 1,500.
Okay.
12, it is a good assumption since the sample size is large.
Okay.
13, Daniela was right, and it's the central limit theorem.
Mm-hmm.
14 is Z. 15 is negative 0.9.
Okay.
16 is 0.184.
Okay.
17 is fail to reject the null hypothesis.
Mm-hmm.
18 is we have insufficient evidence that the true population mean is less than 150.
Okay.
19 is type 1.
Okay.
20 is the probability of a type 2 error will increase.
Okay.
And 21 is 0.05.
Got it.
All right, team. Awesome.
See you next week.
See you Tuesday.
See you. Bye.
Bye.